Hey everybody, Bill Young again. Today is Saturday, April 18th, and this would have been the day of the North Carolina Furniture School ShopBot camp. We had a whole series of camps coming up, starting at the one that would have been at Stuart Kent's Furniture School in Farmville, North Carolina. But the COVID-19 put a pause to it. We're still going to have them. There's a bunch coming up. We just postponed it till things sort out a little bit, and it's safe to have people together. But it's about a little after 10, so we would have all had a belly full of donuts and been drinking Lenoka coffee, and we would have started presentations. So I'm going to try to go through one of the ones that I thought would be an interesting to start out with, and that is some of the work I've done with digital fabrication and building buildings. I've been involved in that for a while. It's been fascinating to me. I've gotten to do a bunch of different things with my collaborator Robert Bridges, but I kind of want to show a little bit of some of the ones I've been working on and talk about them a bit, and we'll see if I can handle this technology. Hold on for 1 second. Boom. We'll see. So back in 2004 or 5, the Center for Bits and Atoms in MIT bought the first ShopBot ever to go in a fab lab. It was in the South End Technology Center in Boston. And Ted Hall and I had an invite to go up and visit them and see what they were working on, and it was really amazing. It was sort of overstimulating to see all the work they were doing. But at the end of the meeting, Neil Gershenfeld, the director, said, "You ought to meet this guy, this Professor Larry Sass, who's the head of the Digital Design Fabrication Group in the Architecture Department." So we shot over to Larry's lab real quick, and it was really good. He was doing some really, really neat stuff. He and I kept up, and he showed me the first thing that he had done in this group was this, called an instant shed. And it was plywood cut, all friction fit, and it was just fascinating to me. They just kind of hammered it together, and in theory, all you needed once you had the parts was a mallet to be together. It all interlocked, and it was really kind of neat looking. And I was fascinated by it. It was all just cut out of sheets of stuff. They even made the ladder that assembled it. That's Larry standing in the doorway. And I was just fascinated by this. I thought it was a very, very cool project. So a couple of years later, Larry got in touch and he said, "I've been asked to do a building in the New York Museum of Modern Art home delivery show." And it was a show of prefab houses. They're going to build actual houses in a lot next to the MoMA. And he said, "Are you interested?" And he was going to do a New Orleans style shotgun house. So of course I was interested. So his idea was that you would take a CNC machine, a big pile of plywood into a neighborhood, and you'd start cutting. And you would do a neighborhood worth of buildings, and you'd cut the first part of each house first, and then you would cut the next part, and people would assemble their own houses, and it would be sort of foolproof assembly. They would, this part would only go together with that part, and you couldn't put it together. It was either wouldn't go together or was right. And it sort of had this, it was sort of neat, sort of a factory in a way. But each one was built on site. It was an on-site factory. So I had 2 ShopBots in my shop in Exmoor, Virginia, and he sent 2 grad students down to spend almost a month with me. And they were creating files, and I was cutting. And they all locked together, had different kind of key-shaped pieces. It ended up being 600 sheets of plywood and about 50 sheets of plastic that we trucked from Virginia to this lot in New York City, right in Manhattan. And everything was left tabbed in the sheets, all cut in the backwards order. So it was all stacked so that You took a part off, put it in, the next part fit, and it just worked along that way. And in theory, all the parts were labeled, and in theory, all you needed was a laptop and a mallet. And the laptop just gave you the assembly instructions, how it all went together. This is one of the students putting it together, and this is the final house. And all the gingerbread, the stairs, all the parts were CNC cut. It was a very, very cool project. We also did a couple other little projects with them. This was a shed that we did in the Austin, Texas Maker Fair, and did some little projects, playhouses, dog houses, and all, just trying to see where we'd end up doing, what kind of things you could do with this technology. So in 2009, the Guggenheim Museum and SketchUp, the software people, had a contest to design emergency housing for students. And Robert Bridges, my buddy Robert Bridges, we had been working, I've been helping him. He has a construction company, he's a contractor. We had done some curve shapes. This was a vaulted ceiling, and it was astounding how strong the curves were. I sort of knew that curves were pretty strong from building boats, but it really worked well. They all slotted together. It was a really kind of a prefab sort of thing. So Robert got thinking maybe that might be a neat shape to enter in this contest. So he entered this design he came up with called Shelter 2.0. And it didn't win. There were thousands of entries, but we thought that the best thing, you really can't tell what a structure's like until you actually build one. So we got the materials and started building one next to the shop, between the shop and the building next door. And it was really kind of neat. We liked the space, and it all knocked down flat, so you could flat pack it and ship it, fit in a shipping container. So we sent a bunch to Haiti, worked with a group, an orphanage down there. And Robert and Peter Soran, who was a minister here, went down and they built a bunch. And the first one, they had to help a lot. After that, it was all volunteer labor, and it all just went together. We also worked with a group called the Mad Housers in Atlanta that builds housing for the homeless. And we've recently been working with the House of Mercy in Rochester, New York, and a group called the Andover School that Zach Owen is a teacher at. And he's been making shelters of various kinds, the Shelter 2.0 design, and donating them to the House of Mercy and the Peace Village homeless tent city. And this is his class. They put one together. This is on the grounds of the House of Mercy. These are the students. This is a plaque they had mounted on there. They've been built in different places. This was in California. It was a little classroom for the Maker Faire for doing workshops. This is one Artistry Studios built that I thought was really neat looking. They made it a little bit shorter. The Maker Camp that Make Magazine does held their camp in a shelter. This was in Cambridge at the grounds of MIT. That's the Stata Center, the Frank Gehry design in the background. And it was used at the one of the Fab annual get-togethers, the Fab Foundation annual get-togethers. I can't remember what year it was. We also set up with the Open Desk guys. We set up a thing we called Make Local, where we set up a little fabrication facility inside a shelter at the Maker Faire in New York, and people could come and order online from a catalog of different stool designs. And we would fabricate them on site and they'd take them home. It was a very cool project. So Robert and I have always been big fans of timber framing. And we like the construction the way it's all locks together, big timbers and all. But it's really hard to find good timber these days, at least locally here. All the sawmills have closed. You can't buy 8x8s and 6x6s that aren't, twisted and, just a kind of it's just hard to find. So we came up with this system we call timber ply, and it's all laminated, interlocked together. The joinery is designed into the parts initially so that you leave out a layer to make a mortise, or you add a layer to make a tenon. You leave places where things can lock together. So we were asked to build a boathouse for a friend of ours, and we decided to try this timber ply technique. This is a sample of the kind of joinery. And you'll see those little pieces in the corners, those little odds and ends pieces are little dovetailed keys. We came up with this keying system that sort of acts as clamping, so you don't have to have a million clamps. We glued it all up using a press and an I-beam just made with wedges, just jam it all together. Did just a little bit of traditional timber framing tools to clean out the glue in the mortises. We had used Gorilla Glue, which is kind of the foamy stuff, which cleans up nicely. It all went together in about a half a day. Everything locked in, the mortises locked, the tenons locked into the mortises, all the bracing. It turned into just a really, really nice building. You can see it looks traditional timber frame, but it's all done in plywood. It's it's kind of like having t-shirts done. Once you've done the design, it's easy to cut. You know, it's expensive to get one t-shirt done, but after that, they become way, way cheaper because all the legwork's been done in advance. But the building turned out beautiful. It's really a nice building. We also did a couple of hollow ones. This is a corner post for a project we worked on. So in 2013, we were asked to work on a project, a collaboration between the WikiHouse group and SketchUp magazine again. And it worked out, they wanted to build a demo building in New York at the Maker Faire there. So we each cut, Robert and I, we each had CNC machine ShopBots in our separate shops, and 15 miles apart maybe. So we split the job in half, and he cut half and I cut half. And all holds together with little wedges and things like that. So, and then we trucked it all to New York and put it together. And it was really kind of an interesting way to have something fabricated in two different places and all the parts join and fit together when they get to their final destination. So one of the grad students that I worked on with the MoMA project was Dennis Michaud. And he had an idea that you could sort of digitally augment traditional 2x4 construction. That a lot of this plywood stuff was very cool and made a lot of sense on some levels. But if you couldn't get a building permit for it and couldn't get an occupancy permit, the building inspector didn't understand it. It was a sculpture and not a house. So he started this company, Farmville, to use CNC technology to build buildings that could only be assembled one way to sort of augment traditional construction. So here we're cutting some parts for bottom plates with mortises in them for some of his test structures. All the parts were labeled, they all had tenons, they all had little pockets so that you could pocket screw toenail with drywall screws or deck screws. This is a shed that went to New York, and everything just fit together. It really was kind of an amazing project. This was dry assembling one of the sheds in my shop in Virginia, and that's Dennis on the ladder. So we stayed very interested in this digital analog workflow combination and started exploring some other ideas of doing, making it easier to do things like a bird's mouth on a rafter that you have to sort of cut with a jigsaw and cut with the skin, sort of notch the corners. And so we came up with some jigging systems that you could use just cordless power tools to cut these birds' mouths and cut different details. This is a jig to use a router and a follower template to cut a little saddle in a bottom plate so a stud could fit in there. So you couldn't the studs had to be in the right centers. If the jig was created right, then you could make bottom plates all day long and the studs would be centered properly no matter what. They either fit in the pocket or they didn't fit in the pocket, or they were wrong. We did some other stuff too. This is a part for the shelters. There are lots of places where there's a disaster where you don't have enough infrastructure to have CNC machines, but you could have a generator, some power tools, and a set or two of accurately cut templates that you then use with a hand router to duplicate. And you can just make them all day long. You can make multiple copies of the templates. All you need is a handful of, common plunge routers, jigsaws, maybe some skill saws, and you'd be in business. This is a shelter that was done that way, out of 2x6 lumber, just traditional construction, but using templates to make the parts. So if you're interested in finding out more, we have information on shelter2.0.com. This has really been sort of a fascinating series of projects. We're still really interested in it. We're always experimenting with these kinds of using digital technology to make it easier building houses. Labor is tough. It's hard to find skilled carpenters and craftsmen to build houses these days. We've killed all the shop classes, so they're not running through. It's rare to have a carpentry class or a wood shop class anymore. We're not trying to put carpenters out of work, but we're looking at ideas to make it easier for less skilled workers to be a part of building, either whether it's the homeowner or whether it's a new worker in a construction company, to make them more productive. So anyway, this would have been my first presentation at Stuart Kent's camp. And I'll work on some others. I have a couple others that I'd planned on doing, but anyway, this would give you a little bit of an idea of what might happen at one of the camps. And y'all take care and stay socially distant.